Hello all. We will be trying to solve the next problem now. So in this problem, we are going to have steel as well as aluminum. So the steel have a length of 2.5 meter and the aluminum have a length of 2 meter. And you are going to apply a horizontal load along x-axis, which is equal to 10 kilonewton. And the area of cross-section of steel is given 50 millimeter square. The Young's modulus is given 200 gigapascal and length of steel is given 2.5 meter. So similarly, aluminum area of cross-section is 40 millimeter square. Young's modulus is 70 gigapascal and the length is 4 meter. Length is 2 meter. So what we are going to do in Abaqus, we are going to model the entire geometry, which is now 4.5 meter. Out of this, the length is 4.5 meter. And out of this 2.5 meter is belong to steel. So we will be using some partition technique where we will enter this ratio like the portion of steel over the total length 2.5 meter divided by 4.5 meter, which will be approximately equal to 0.555. So depending on that one, we will make a geometry in Abaqus, then we will partition it. That is what we are going to learn in this class. So let's take the Abaqus window. Let's take the Abaqus window. So initially we will create the part. So what we need to create a part, we need to create a line which have a length of 4.5 meter. So 2D planar, then wire. So let's say it is 10. Continue. So we will draw the line. The first point is 0, 0. And the second point is 4.50. So you create a line of 4.5 meter length. Cancel this one. We create a line with 4.5 meter length. Click done. So this is what we are going to get it. So now this line we will partition into two items. The left part will be belong to steel, and the right part is belong to aluminum. So for that one, you will be having an option here, tools. There is a quote unquote partition. On the partition, what we are going to do, there is an enter parameter. So this edge we are going to divide it into two items. The first part is 2.5 meter length and second part is 2 meter length. So you are going to have enter parameter section. Then Abaqus is asking me to select the edge to partition. I will select this line, then click OK. So now you can see the direction in which it is showing. It is asking you which part we need to partition. Now the direction is from left to right. So from left to right, when you look at, I need steel of 2.5 meter length out of 4.5. So 2.5 divided by 4.5, which is approximately equal to 0.555. So create partition. Now you can see the left part under this yellow dot, the left part, we have one part and right part, we have another part. So the left part we will be assigning for steel and the right part we will be assigning for aluminum. After the part, what we are having, we will go to property module. Here we want to create two material. One is for aluminum and the second is for steel. So let's create material number 1. So I will name this material as steel. So what we need to enter? We need to enter elastic properties. Young's modulus is 200 into 10 raised to 9 and Poisson ratio is 0.3. Click OK. So I have created a material steel. Then I have to create another material. Again, I will go to click create. So next part is aluminum, L, mechanical, elastic. Young's modulus is 70 gigapascal and Poisson ratio is 0.3. Click OK. Now we have steel as well as aluminum. Two material we have created. Now what we need to create? We need to create a section here. So just section manager, create section. What we are going to create first, we will create steel section. So I name it as steel section. What we are having, beam, then truss. So steel section having truss cross section. Continue. Then we need to select which type of material. We are looking for steel material. And the area of cross section, it is 50 into 10 raised to minus 6. And 50 into 10 raised to minus 6. Click OK. This is 50 into 10 raised to minus 6 millimeter square is a cross section of the steel. Now we have to create a section of aluminum. So create. I have to create section 2. Let's say it is, we call it as aluminum section. Press continue. So we will select aluminum. So cross section of aluminum is 40 into 10 raised to minus 6 millimeter square. Sorry, meter square. It's not millimeter square. Sorry, it is meter square. Click OK. So we have steel section and aluminum section, which have truss as well as the area of cross section we have entered in meter square. So done. Then after that, what we are having assembly. So after that, we have to assign the cross section. So click section assignment manager, click create. So we will just select the left part. Now we select the steel part. Click done. Then I will assign the steel section for that part. Click OK. Now the next part we have to assign for aluminum cross section. Click create. I will select the right click. Click done. So I will select aluminum section. Okay. So now the entire geometry I have assigned. Left part I have assigned steel. Right part I have assigned aluminum. Done. Now we can go to assembly. Assembly and everything is same. Assembly we keep bother. We will do everything like in last time. Click OK. Nothing. Step. We will go to the same. Initial static general. So implementation it is 1 1 1 1 1 1. Click OK. Then what we are having, we are going to have interaction. Nothing is to be done in interaction. Then you are going to have load. In the load, we will create concentrated load on the right hand. Load, create concentrated load on the right hand. Continue. Select this point, right point. Click done. So what is CF1? CF1 is 10,000 Newton. 10,000 Newton. So we got the force here. So similarly, we are going to create displacement boundary condition on the left hand. Click done. So we will fix everything. Done. Then after that, what we are going to do, we have to do the meshing. So we have to select the part. Then what is the seed? We will do the seeding. So seeding, it is asking to 0.45. What we need actually, steel we will divide into one element and the aluminum we will divide into one element. The length of the steel is 2.5 meter. So I will just select 2.5. Then the right side aluminum, if you know, it is only 2 meter. But when you look at here, the first part Abhagat is going to do with 2.5. The next part, since 2.5 is not available, it will do with the remaining part 2 meter. So that is what it is going to do. Click done. So you can see the left part is 2.5 meter and the right part is 2 meter approximately. So then you have to do the meshing. Click meshing. So okay to mesh the part. Yes, meshing is done. Then after that, we need to select the element type. So we will just select the total element type. Then which element I have to select? I have to select the element truss. The element truss I will select. Click OK. Then everything is done. Now before solving that one, I will save this data. I will just select the work directory like in the last problem. So desktop, applied FEA. So we will create another geometry like problem 2. So this is my work directory. Click OK. Then I will save this one as problem 2. So just in problem 2, I will just say problem 2. So then we will create the job like class problem. Let's say problem 2 is the job. Click OK. Done. Then submit. Submit. And it is running. So it is completed. We will look at the result now. visualization, von Mises stress, you can see here. What we are interested is S11. So S11. So now if you look at the red part, it is showing 250 megapascal. And the blue part, it is showing 200 megapascal. It is 2 into 10 raised to 8 and 2.5 into 10 raised to 8. So which indicate that aluminum is having a stress which is in red color. It is 2.5 into 10 raised to 8, 250 megapascal. And steel is having 2 into 10 raised to 8, that is 200 megapascal. Let's look at the values, Puri, probe values. Then nodes. Let's look at the node number 3. This is node number 3. You can see that S11 is 2.5 into 10 raised to 8. And if you look at node number 2 is belong to steel as well as aluminum. So one value you can see 2 into 10 raised to 8, which is belong to steel. And other value you can see 2.5 into 10 raised to 8, that is belong to aluminum. So let's look at the node number 1. You can see the stress is 2 into 10 raised to 8, 200 megapascal. So then after that, what we are interested in the displacement. So displacement, we are interested in U1 x-axis displacement. So we will just look at row values. So node number 3, you can see node number 3 is 0.009 meter. Just compare it with what we have derived in the class, 0.009. And node number 2, if you look at it, is 0.00249. Just compare it to that one. And node number 1 is 0. So similarly, if you want to look at the reaction force, we will select RF. Then RF1. So again, go to the reaction force is going to come here, which you can see it is minus 10,000, which is in blue color. So this is the solution of the second problem. Strain also you can look at. It's E11. So you can see here the strain in aluminum is 3.57. Just look at what is the strain in aluminum. It is 0.00357. And look at steel. It is 0.001. I think it is matching with what we have derived in the class. Thank you. Thank you.